In the year 1683, in the Swiss city of Basel, a mathematician named Jacob Bernoulli asked a question that sounds like it belongs to a banker, not a philosopher. Imagine a bank so generous it pays you 100% interest in a year. Put in one coin, and a year later you have two. Simple. But then Bernoulli asked the dangerous question. What if the bank didn't wait a whole year to pay you? What if it paid you half the interest after 6 months, and then let that grow too? You'd end up with a little more than two. And what if it compounded every month, every day, every single instant, forever? Here is the part that should stop you. The answer is not infinity. Compound the interest faster and faster, and your money does not run away to the stars. It climbs, and it slows, and it slams into an invisible ceiling at a very specific number, 2.71828, a number nobody chose, nobody designed, and nobody could get past. Bernoulli had stumbled onto one of the deepest constants in the universe. He just had no idea what he was holding. That number is called E, and here is why this is not a story about banking. Because E does not stay in the bank. This exact same number, 2.718, describes how a population of rabbits explodes. It describes how a chunk of uranium decays into lead. It describes how a hot cup of coffee cools on your desk. It is the shape of the bell curve behind every statistics class, every opinion poll, every measure of intelligence. It is the curve of a chain hanging between two posts. It secretly decides the odds that you will ever find your lost hat and the best possible strategy for choosing who to marry. And it is running, right now, inside the artificial intelligence in your pocket. One number, hiding in all of it. The question of this video is simple and enormous. Why? Why does a constant born from a banker's greed turn out to be the master key to the whole of nature? To answer that, we have to understand what E actually is, not the trick, the machinery underneath it. Let's build it from nothing, the way Bernoulli did. One coin, 100% interest, compounded once a year. You end with two. Now compound twice, 50%, then 50% on the new total, $2.25. A little more, because the interest earned interest. Compound it monthly, and you get about $2.61. Compound it every day, 365 tiny slices, and you reach $2.71 and change. Compound it every hour, every second, every instant, and the number stops moving. It settles, forever, on 2.7182818. Written as a formula, you are computing 1 plus 1 over n, raised to the power n, and letting n run to infinity. Watch the staircase climb, each step smaller than the last, the whole thing pressing up against a ceiling it can approach but never touch. That ceiling is E, growth feeding on its own growth, doesn't explode, it converges. And the number it converges to is woven into the fabric of change itself. Now here is the property that makes E not just a number, but the number. Draw the curve of E raised to the power x. It starts low, then sweeps upward, faster and faster. Every curve has a steepness, a slope, at each point, telling you how fast it's rising. For almost every function in mathematics, the slope is a different creature from the height. But for this one curve, something miraculous happens. At every single point, the slope of e to the x is exactly equal to its own height. How fast it is climbing equals how far it has already climbed. The function is its own rate of change. It is the only function in all of mathematics that casts itself as its own shadow. Sit with what that means. It means e to the x is the mathematics of anything whose speed of growth is set by how much of it already exists. More rabbits make more rabbits. More money earns more money. More radioactive atoms means more decay. The universe is full of things that grow or shrink in proportion to themselves, and every one of them, without exception, speaks the language of E. For decades, the number sat in the mathematics of the world, unnamed and half understood. John Napier had brushed past it back in 1614, when he invented logarithms, a tool to turn brutal multiplication into simple addition, and E was hiding silently in his tables, though he never saw it clearly. Bernoulli found the constant in 1683, but could not say what it meant. And then it met the one mind big enough to hold it whole. Leonhard Euler, the most productive mathematician who ever lived. In a letter written in 1731, Euler gave the number its name, E, the letter it still carries 300 years later. In his masterwork of 1748, he calculated it to 18 decimal places and placed it at the very center of mathematics. He proved that E is irrational. Its digits run on forever with no repeating pattern, a number that can never be written as one whole number over another. And more than a century after him, in 1873, Charles Hermite proved something even stranger. E is transcendental. It is not the solution to any equation you could ever write with whole numbers and powers. E doesn't just refuse to be a fraction. It stands entirely outside the reach of ordinary algebra. Euler also handed us the most beautiful way to see E, a recipe made of pure addition. Take 1, add a half, add a sixth, add a 24th. Keep going, each new piece a fraction of the last, shrinking impossibly fast. 1 plus 1 over 1, plus 1 over 2 times 1, plus 1 over 3 times 2 times 1, and on forever. Pile up that infinite staircase of ever tinier pieces, and it lands exactly on E. This is the same number as the compound interest ceiling, the same E, reached by a completely different road. That is the first clue that E is not a coincidence of banking. When the same number arrives from two directions that have nothing to do with each other, mathematics is telling you it has found something real. Not invented, discovered, like a mountain that was always there, seen at last from two different valleys. And once you know its face, you start seeing E everywhere it has no business being. Take randomness itself, the bell curve, the gentle hill that describes the spread of nearly everything that varies by chance, from heights to test scores to measurement errors. Its exact shape is built from E. Or take a small, strange puzzle. Shuffle a stack of numbered letters into numbered envelopes completely at random. What are the odds that not a single letter lands in its correct envelope? As the pile grows, that probability homes in on 1 over E, about 37%, and it barely changes whether you have 10 letters or 10,000. And here is my favorite. Say you must hire the best candidate, or choose the best partner. From a line of options you can only judge one at a time, with no going back. The mathematically optimal strategy is to look at the first 37%. That's 1 over E again. Reject them all, no matter how good, and then grab the very next one who beats everyone you've seen. E decides how long you should look before you leap. A number born in a bank now quietly governs love, luck, and chance. But the deepest secret of E is what happens when you feed it something imaginary. Euler discovered that E raised to an imaginary power does not grow at all. It spins. E to the ix traces a perfect circle, turning the runaway engine of growth into the smooth engine of rotation, of waves, of everything that oscillates. And when you turn that spin exactly halfway around the circle, when you set the angle to pi, the whole machine collapses into a single line that has stunned every mathematician who ever saw it. E to the power I pi plus 1 equals 0, the most beautiful equation in mathematics. And at its beating heart is E, the number from the bank. The constant of endless growth turns out to be, in disguise, the constant of rotation, of circles, of light and sound, and the quantum waves that everything is made of. Growth and spinning, it turns out, are the same thing wearing two masks. And E is the face underneath both. This is not a museum piece. E is running the machinery of your life right now. Every loan, every mortgage, every savings account uses the continuous compounding curve Bernoulli first chased. Archaeologists read the age of a bone or a scroll by measuring how much carbon-14 has decayed, and that decay is nothing but E to a negative power, ticking down. And here is the part that should stop you cold. Every time an artificial intelligence makes a choice, every large language model, every image generator, the very system answering questions on your phone, it turns raw scores into probabilities using a function built on e to the x. It is called the softmax, and it is the reason an AI can say, "I am 70% sure." Deep inside the most advanced machines humans have ever built, at the exact moment they decide anything at all, they are computing the number, a Swiss banker's question uncovered in 1683. From compound interest to the mind of the machine, the same E, all the way down. So why is E so special? Because E was never really about money at all. E is the number the universe reaches for whenever something grows or fades in proportion to what it already is. It is the rate of a rising population and a dying atom and a cooling cup of coffee. It is the shape of pure chance and the secret of the most beautiful equation ever written. It is the pulse inside every exponential curve and the quiet arithmetic running the intelligence in your pocket. Bernoulli didn't invent it. Euler didn't invent it. Nobody did. It was always there, waiting inside the machinery of change, until human beings grew clever enough to find it, and brave enough to give it a name. 2.718281 number. Infinite disguises, the mathematics of natural change itself. If seeing why a number rules the universe means more to you than being told that it does, subscribe, because that is the only kind of story we tell here. I'll see you in the next dimension.